Pre-algebra, the second part of 10-3, solving equations with variables on both sides. Continue taking notes. Last time we did number 9, which involved the distributive property. This time we're going to do number 10, which also involves the distributive property. All right, nice and filling the screen. Okay, copy that down. Number 10, 5, open parentheses, 3h minus 2, close parentheses, equals 2, open parentheses, h plus 8, close parentheses. Do you recognize the distributive property? Here's what it looks like. We've got a number right here multiplied by a quantity in parentheses that where you have two terms separated by addition or subtraction. And not only do we have the distributive property on the left, do you recognize it on the right also? Again, a number multiplied by a quantity in parentheses. In this case, it's got two terms. It could have more than two terms, but you won't get any of those. Separated by addition or subtraction. All right, so we're going to use the distributive property on both sides. Distribute this 5 to the 3h. It means 5 times 3h is 15h. This minus is going to basically end up coming down. And then distributed the 5 to the 2. 5 times 2 is 10. Okay, now we're done with the parentheses over there. 2 times h is 2h, plus 2 times 8 is 16. And now we've gotten rid of the parentheses there too. Now we're down to the fact that we have variables on both sides. Let's get rid of the one over here by subtracting 2h from both sides. That gives us 13h. Bring down the minus 10, bring down the equal sign. This goes away, which was the reason we did that. Bring down the plus 16. I'm hoping this is getting to be simple for you here now. Plus 10, bring down the 13h, minus 10 plus 10 goes away. Bring down the equal sign and do 16 plus 10. Which is 26. That'll make our work nice and easy here. Divide both sides by 13. And h equals 2. Okay, let's go back and deal with a problem with fractions in it again. Copy number 11. 5 plus 1/2 y equals 3/8 y plus 6. Does anybody recognize what would be problematic here? There's something we don't like about this problem. That would be that the y terms have fractions with different denominators, and that makes our life a little more complicated. But the thing is, we could change 1/2 y into eighths very easily. You should know that off the top of your head. 1/2 is how many eighths? 4 eighths. So let's just go ahead and do that and just copy everything else. I know that's cumbersome, but that way we don't lose track of anything. Okay, all we've really got here is y's on both sides, so let's subtract one of them. Subtract 3/8 y from both sides. We'll bring down the 5, and this is 4 minus 3 is 1/8 y, and that's positive. Bring down your equal sign. This goes away, which is why we did that. Plus 6. Okay, we're still trying to get y by itself. And so that it's got this 5 over here. So we're going to subtract 5 from both sides. This goes away. 1/8 y equals 1. And then to get rid of the 1/8, the fraction in front of a variable, you multiply by the reciprocal, which would be 8 over 1, which boils down to 1y, or just y. Oops, I forgot to multiply by 8 over 1 over here. 8 over 1 is just the same thing as 8, and it doesn't make sense to write that as a fraction over there. So y equals 8, because 1 times 8 is 8. And this problem should bring joy to every pre-algebra student's hearts. Looks like we've got both distributive property on both sides and fractions on both sides. And our fractions do not have the same denominator. We'll see how that plays out in the end here. Let's take care of the distributive property over here first. Do you recognize it? A number multiplied by a quantity in parentheses with at least two terms, and they're separated by addition or subtraction. Okay, so we're going to take care of the distributive property there. We're going to distribute the 2 to the x. 2 times x is 2x. The minus is going to come down. And 2 times 1/2. Do you know that off the top of your head? It makes 2 halves, which is just 1. You can use your calculator if you need to. Then over here, we're going to distribute the 4 to the x, which is 4x. Bring down that plus. And 4 times 1/4. Do you know that? 4 times 1/4 is 4/4. And isn't that beautiful? Because that just makes 1. And look, the fractions are all gone, and the parentheses are all gone. All right, so now we've got variables on both sides. If you want to subtract 4x from both sides and keep your x's over here, that's fine. It's going to give you a negative. I prefer not to deal with negatives. So I'm going to subtract 2x from both sides and get rid of it over here. Whoops. So I'm going to, this negative right here goes with this 1. It has nothing to do with the 2x. Minus 2x minus 2x. This goes away, leaves me with negative 1. 4x minus 2x is 2x. And bring down the plus 1. We're trying to get x by itself. Subtract 1 from both sides. That gives us negative 2 equals 2x, because this went away. Divide both sides by 2, and that gives us negative 1 equals x. Negative 1 equals x. You can handle problem number 13 yourself. I hope that you do recognize that this requires the distributive property. You go ahead and pause the video, turn it back on when you're ready for the answer. Okay, so we distributed the 4 to the 3r, which gives us 12r, brought down that minus, and 4 times 2 is 8. Bring down your equal sign, and your 4 minus 12r. Then we recognize that we have r's over here and r's over here, so we got to get rid of them from one side or the other. This is minus 12r, so we added 12r and added 12r. Over here, that gives us 24r. Bring down the minus 8, and when you get rid of the 12r, you're left with 4 over there. Add 8 to both sides. Gives you 24r equals 12. Divide both sides by 24, and that gives you 12 over 24, which is the same thing as 1/2. All right, we've got to do number 15 because it's kind of a special kind of problem too. We've got two terms up here. That means things that are separated by addition or subtraction. And then a denominator underneath the whole thing. And that's sort of a special situation. Okay, this fraction line, you can think of it almost like a grouping symbol, like parentheses. And we're going to have to get rid of the fact that this whole side is divided by 2. This 2 is on the bottom of the fraction, so it's being divided by 2. So to undo that, we're going to multiply both sides by 2. Now this is a little tricky. You have got to multiply the whole side by 2. So we're going to put this in parentheses to show we're multiplying the whole side by 2, not just a piece of it. Okay, so over here, this accomplishes what we wanted, and it makes that go away, leaving us with 3a minus 4. Bring down the equal sign. Now this is the distributive property again. The 2 gets multiplied by the 5, which is 10. Bring down that minus. And the 2 gets multiplied by the 2a. 2 times 2a is 4a. Now we've got it down to something you can handle. It does have variables on both sides. This minus 4a, we can get rid of it over here by adding 4a to both sides. 3a plus 4a is 7a. Bring down the minus 4. The minus 4a plus 4a goes away. Add 4 to both sides. 7a equals 14. It's always nice when it works out to something that comes out to a nice even number. Divide both sides by 7. And a equals 2. For number 15, a equals 2. Oh, I can't let you go without giving you a couple of word problems, so let's give this one a try. Number 16. Mandy and Mackenzie spent the same amount of money. The same amount of money, to me, says equal sign. Their names are Mandy and Mackenzie. Let's put Mandy on this side and Mackenzie on this side. They spent the same amount of money. They both played the same number of games, and Mandy played 50-cent games and spent $10 on refreshments. Mackenzie played 75-cent games and spent $6 on refreshments. How many games did each person play? How many games? When it says how many, that means X. So the number of games is X. It's always good to define your variable. X equals the number of games. Okay, always read the question again. Mandy and Mackenzie spent the same amount of money at the arcade. They both played the same number of games. Mandy played 50-cent games. The way we're going to write that, that's 50 cents times the number of games she played. So that tells what she spent on games. And she spent $10 on refreshments. So we're going to add that on, and $10. The other person, Mackenzie, played 75-cent games. So that's going to be 0.75 times the number of games, and spent $6 on refreshments. We've solved quite a lot of problems, and the hard part here is setting up the problem. So I'm not going to work all the steps. You can work all the steps and pause the video, and I'll give you the answer when you come back. And the correct answer is 16 games. One more problem for you today. Number 17 says the square and the equilateral triangle at the right have the same perimeter. The same, that means equals. Find the lengths of the sides of the square. Okay, so if it's a square, each side is 2x plus 1. And they said that it's an equilateral triangle, so each of those three triangle sides are 3x minus 2. Now let's go back to what the question said. The square and the equilateral triangle at the right have the same perimeter. Perimeter is the distance around. They're equal. Let's put the square over here, the square perimeter, and the triangle perimeter over here. Well, you've got two choices here. I would prefer to do 4 times one side length. You see how that creates a problem with the distributive property in there? And then for this one, it would be 3 times 3x minus 2. Now, if you don't like that or you don't understand that well, it would be fine for you to do 2x plus 1 plus 2x plus 1 plus 2x plus 1 plus 2x plus 1. Do you see how that's the perimeter of the square? You could totally do that and then add all that stuff up. And for the triangle, it would be 3x minus 2 plus 3x minus 2 plus 3x minus 2. And you could add all that stuff up. I think that's kind of cumbersome. I'd rather do this. 4 times 2x is 8x. Bring down the plus, and 4 times 1 is 4 equals 3 times 3x is 9x. Bring down the minus, and 3 times 2 is 6. Those of you who are paying attention here, you see you got 8x over here and 9x over here. I'd rather subtract the 8x from here. That's going to give me 4 equals 9 minus 8 is 1x, or just x, minus 6. Add 6 to both sides, and 10 equals x. Now, is that your final answer? It says, find the lengths of the sides of the square. They're all the same, so we only have to do one of them. I'm going to get rid of this right here. So 2x plus 1, plug in 10 for x, gives you 20 plus 1, which is 21. And it didn't give us any units or anything, so we'll just leave it at 21 or put 21 units. Wasn't that fun? All right, finally the video's over.